Welcome to Vansig Maths. Today we look at how to get a polar form of a complex number. So a complex number is when you have a number in such a form, a plus bi, where we know this part is the real part, and you have the imaginary part. This imaginary part arises due to when you have the root of -1, I will say this one is I. So when you are plotting in a graph on the Cartesian plane, this one represents the x, and this coefficient for imaginary, it represents the y. So if we have our complex here using the two coefficients, then we plot it. So on the x-axis, we have our a units, and on the y-axis, or the imaginary, we have now our b units. So if you can have this diagram, it means we can get that angle. So for polar form, we have the format for polar, have z is equal to r into cos theta plus I sine theta. So from here to here, this one is the modulus, or the magnitude. So the magnitude of this vector, we have the magnitude of the vector. We know that for you to get magnitude, you have this, we square the x units plus the y units, then you find the root. So your r will be the root of a squared plus b squared. So the coefficient of the real part plus the coefficient of the imaginary part, then you find the roots after squaring both of them and adding. So now your r, let's say, for example, let's say our z is 2 plus 3i. So our a is 2, our b is positive 3. So your r will be the root of 2 squared plus 3 squared. So your r will be root, this will be 4 plus 9, have root 13. Now we want to study this diagram. We will realize that we have this part. We have this part, the opposite this side. Then this one is the adjacent, like so. So if you want that angle, or the argument theta, we have tan theta is equal to opposite of adjacent. The opposite side will be, adjacent is a. So we have tan inverse of b over a. So we have tan inverse. For our case, we have our a as 2, our b as 3. So tan inverse of 3 over 2. So also looking at the coefficients, you realize that you also need to consider the quadrants. If it is in the first quadrant, all ratios are positive. If it is in the second quadrant, it is only sine. Then the fourth quadrant is only tan. If the third quadrant is only tan, and the fourth quadrant it is only cos. So you have to consider all those factors when you're finding the argument. So if the coefficients are positive, then the first quadrant. Then if it is negative, then positive second. If it is negative, the third. If it is positive and negative, here. So after finding theta, now you can write your z in terms of r into cos theta plus I sin theta as the